So let's go ahead and kick this thing off, folks. Hey, first and foremost, hey, Happy New Year to everyone. Hope everyone had a really awesome holiday. I know that in our industry specifically, the holidays are not always the same as it is for others, right? Like, and I know, Paul, you come from a 24/7 SOC operation, and many of the folks that join this web series come from similar kind of organizations and teams working 24/7 round the clock, to secure organizations. So I first want to say, I've got a ton of gratitude, and I'm thankful for those of you that put in those long hours, that are working on holidays. But I still hope that everyone had a chance to kind of get together with your friends, your families, your loved ones, and enjoy the holiday break. But with that said, welcome back. First Defender Fridays of 2024. We've got an awesome guest on today, Paul Ihme from Soteria. Is going to come on and talk a little bit about detection engineering and some of the really innovative ways that these guys are kind of leaning into that. Because in my experience, I've seen all walks of life when it comes to detection engineering, right? And what that means, and good ways to do it. And I got to say, Paul's team has kind of innovated a way that it's the ideal state. It's kind of where I think every team should be striving to be. And he gave us a little demo of it at a conference we had at the end of last year called Mission Control. And I said, Paul, I've got to see more of this. I got to hear more about this. And I'd love for our Defender Fridays folks to get to see a little bit about how you guys approach detection engineering over at Soteria. Because again, folks, here's the cool thing about it. His approach is not conventional to any one particular tool. Yeah, these guys build on Limit Charlie, which is awesome. But their approach to detection engineering is very agnostic. It's very much a, hey, this can and should be applied, in my opinion, to any tool set that you're using, right? When you were talking about the fundamentals like detection as code and writing basically unit tests for how do you make sure that the rule that you wrote is going to detect the things that you intended it to detect on. How do you know it's not going to misfire on many other possible things that we call false positives, right? And I'd love to hear more about that, Paul. So I'll go ahead and hand it over to you, and let's hear about your detection engineering awesomeness.
Thanks, Eric, and appreciate the opportunity to be here. First Defender Fridays of the year, and I'll share my screen in a moment and kind of walk through this. And I thought today it could be useful to just go through the process a little bit differently than what I did at the Mission Control conference and talk about, like, let's go and build a detector, from the ground up. But as Eric said, one of the key things that we really focus on, and I think is important to be successful within this, is doing detectors as code, right? Lima Charlie obviously supports that. We're very, very close partners with Lima Charlie, and everything that we do is built around that. So I'll jump in here in a bit and just talk about creating some a sample detection and do it kind of the old-fashioned way, pointy clicky through the GUI, and then back up from that a little bit and talk about how we do it and how folks can do it better. And Eric, you said something that is true, that we're a bit agnostic in how we approach this, and we don't want to tie ourselves too much to it. But that being said, Lima Charlie does provide a lot of really great tools to make this a lot easier and scalable with the way that they built things. So everything today will be 100% Lima Charlie centric, and want to talk about how we do it through there. So with that, I'm gonna roll the dice here, and we'll just see if we can live demo something and create some detections here in
Let
real
me know
time.
if you can share your screen or not. I might need to promote you to a host.
Oh yeah, you're gonna have to promote me. Yep.
Okay, no problem. Here it comes.
And I'll say that as Eric's doing that, we back in the day we used to do a lot of there's a lot of scripting, a lot of MITRE Caldera and those types of things. Everybody see my screen okay? Let me move that out the way.
Yep, it's coming
All right.
through.
So, a lot of manual processes, and these have been refined over the years. But just to set up, I've got a VM here set up, and I've got my invoice.iso that one of my vendors helpfully emailed me today, and I'm going to go ahead and open that up. And I don't know what this icon is, but we'll just go ahead and double click that, and things happen, right? So this is something I did prepare this ahead of time, obviously. And if we look in here, it's a shortcut file. It's going to launch PowerShell, and it'll go and launch a hidden window, download something, a DLL from my GitHub repo, and then launch it with the register server 32 process, right? So pretty standard stuff. But this is, I think, one of the things that I do a lot of, you can read your threat intel reports and go out there and read blogs or whatever it may be. But to the extent that we can go and create the telemetry to reproduce these attacks, I think that's always helpful. Again, uh, uh, Atomic Red Team, MITRE Caldera, a dozen other tools that are out there that you can go and simulate these attacks are helpful. But I'm always prefer starting with something that we can look at and see what this is actually going to look like. So we've got our dev environment here where we're going to wait for these events to show up. And one of the things that's great about Lima Charlie is that everything happens in real time. So these things like pop up pretty quickly. I ran that just a couple of seconds ago, and you can see that it's all here. And so now we've got our PowerShell window up and running. And if I want to go and look at what does this look like, right? So PowerShell ran invoking a web request to my GitHub, writing that file to my temp directory as 1.dll, and then launching that, right? So we can go into Lima Charlie and try to figure out everything that happened along this process. And one of the things that I think our team is really good at is taking these attack techniques and looking at the initial technique, but also kind of looking at what happens afterwards. So for this one, I thought it'd be interesting to just focus on let's look for the register server process execution, like launching something out of a temp directory, right? That's most of the time going to be pretty bad, and we really try to focus on very uh, like very defined and specific types of patterns of behavior. So you can look at any use of this binary, but you're going to get a lot of false positives, right? One of the nice things that Lima Charlie gives you is the ability to just build a DNR rule right out of one of these events. So we've got this execution right here that we know is bad, and we want to be able to catch this everywhere it happens in the future. So we can click over into this, and this is I think one of the really helpful things that we can do within this platform, right? Is okay, we can go and it'll bring this target event down here. We can go and edit the rule, and we can go test our rule to see if it's going to work using the replay API that Lima Charlie makes available. So we can see that this rule will work. If I do the exact same thing again, it's going to fire that one. But we want this to be more generic. We want to make sure that this works not only if it runs on my machine, right? So we're going to take this out. We don't want to just alert if it happens on my VM that's running this right now. We'll be a little bit less specific, and maybe we want to be less specific about the command line, right? So this rule, as written right now, will look for this specific command line being run, but maybe let's look for this just running out of some temp directory, right? So we'll just put the temp path in there. We'll change our operation to contains, and for good measure, we'll make it case insensitive, right?
Because Paul, is it safe to say that if we were too specific, I mean, obviously the command line arguments that you just saw there were 100% the threat, right? If we're going to talk about it that way. So why not leave it ultra specific down to the exact way that the threat manifested itself in your testing?
Yeah, so this comes down to trying to make, you got to find that balance between trying to be generic enough to catch a lot of different attacks, right? But not being so you don't want to be too specific, because then your detectors become way too brittle. So
Right.
now all that the bad guy has to do is like, oh, it's 1.dll, and if I name it 2.dll, then I'll never get caught, and I'll be on my merry way, right?
I love the way you describe it. It's a balance, right? It is a balance between I want this rule to be as resilient as possible, that it will fire in many different versions of this threat, not just the one that maybe I'm looking at. But what if they changed one little detail? What if they ran it out of a different location? What if they used a slightly different command line argument? I would still want to detect upon it, but don't go so far, or we end up in heavy false positive territory.
Right. So and for this one, right, the DLL ran out of my app data local temp directory, right? So you could say we want to look for data, local temp in the path. Maybe that's a good way of doing it. For this example, I'm going to say let's look at any temp, because if it's in C Windows temp or some other temp directory, it's probably also pretty sketchy, and we probably also want to look at that. But we can test these things, right? So I've made these changes but I may have made a typo or something. So let's go and test and make sure this still works. And it does, right? We've got green, everything's good to go. And then we can go and put we can go put our response actions in here. So what do we want Lima Charlie to do? Do we want it to throw an alert or collect some evidence or do whatever? So we do that, we can save the rule, and this is great. So the problem is if we do this, and now we've got a good rule here to look for this execution out of app data local temp here. I can click, save this rule. Well, I've got to give it a port, and we'll say name sketchy rich server execution, right? I can save this rule, and we'll call it Paul's test rule. And you get some good information out of this, right? So now I can see that I'm the one who created this rule. I can see that it was created on this date and time, and that's all well and good. But now if I decide later on, this is too specific. I want everything in temp, right? And I can go and save that rule. Now I know that I still know that I created it. I still know that when I created it, but I don't have any history of this, because if I make that change and now it starts breaking things, we're in trouble, right? So this is where Detectors as code comes in. And also, by the way, if you're an MDR provider like us, or you're running an organization where you have multiple sub organizations set up, now you got to go and copy and paste this rule into a bunch of different places. And anytime you change it, you got to remember to do it everywhere, and so on and so forth. So that's where folks get in trouble, right? So this is where Detectors as code comes in, and uh, I'll take a look at just one slide here. I won't go through the entire presentation that we did at Mission Control, but this is the way that we look at this, right? We want to have an end-to-end process to make sure that there's a controlled way that we're getting these ideas into the hands of our detection engineers. They're building them in a way that works. They're being tested, they're being verified, and they're being tracked over a life cycle, right? So anybody can have an idea. Maybe you read a blog, you saw something on Mastodon, or you went to a conference and saw this new technique that you really like, or you saw something on an incident response engagement, and you're like, man, we need to make sure that we catch this if this happens across our endpoints. This threat intel can come from anywhere. Offensive security, we have an offensive security team. That's great. Any idea can be put into a Jira repository. That's what we use to track things, and that gets passed off to our detection engineers, and they can go and look into that. They'll create a new detection rule in the repository, commit that into GitHub, put it in an issue branch. But I think the important thing, and what I'm going to go into next, is this next piece here that Eric touched on a little bit earlier, right? Using GitHub Actions in our case, but whatever you need to do to make sure you're doing unit testing, because detections as code is made, the philosophy behind it is made to mimic a lot of what happens in software engineering. And good software engineering teams test their code every time they put it into production. Every time they make a change, they go and test for any sort of regressions to make sure it doesn't break any previous functionality, so on and so forth. So we make sure that happens, and we'll notify our team of those outcomes via Slack and all that good stuff, but it doesn't go past here unless it passes these unit tests, right? Then it goes on to our detection engineers, because somebody else wants to spot check this to make sure that what we're doing is sane. Approve a PR, GitHub Actions, hit the Lima Charlie API, and now it's in production, right? So this is the set of controls that we put into place to really mimic what software engineering teams do, because this is a practice that's been around much longer than the idea of detection engineering. They're doing pretty good things out there to control what happens. So we want to mimic those. And one thing that I'll step back to is this replay API to us was really, really interesting, because it's great to be able to test these things, but I don't want to necessarily have to go into the GUI and copy and paste this every time. So if you go into the Lima Charlie documentation, you can see that you can create rules in a file. You can hit the Lima Charlie replay API, and it will run that same routine against it, and it will tell you whether or not it worked, and if it didn't work, why it didn't work, right? So and by the way, there's also a Python version of that, right? Validate rule with a rule content piece that works really well. So this is a test rule that's in the format that our team uses, right? So going back to the same concept, we're going to be looking for the register server 32, registering a DLL that's in a temp directory. And another thing that we think is really important to enforce as part of your detection engineering processes is you can have the greatest rules ever, but if you've got your brand new analyst that started yesterday and has never seen any of your rule content before and they get an alert fired, you're going to want to make sure that they actually know what's happening here, right? You can have a great descriptive name like I've got here, and I don't know if that's big enough. Maybe I need to make this a bit bigger. If I can remember how to do that. There it goes. So we got a descriptive rule, but we also have just a plain English description. Like, what is this saying? What is it looking for? This identifies when this binary executes a DLL that's in a temp directory. You know, this should be considered abnormal. There's not really a normal use case for this. It's well documented. Sometimes you'll have detectors where you can say like, hey, this is a common false positive condition. So, be aware, or common benign position. And you can also, as part of your, this is our actual detection logic. And in your report actions, you can include this metadata in there as well. That way it just shows up right within your detection. So we think that's really helpful. Give your analysts the information they need to be able to make a quick decision when this thing fires. If they've never heard of this, give them some links to go click on and learn more about it and so on and so forth. But the interesting thing that we did here is VS Code is an Electron app, which means it's basically a web browser that looks like an app, and you can write extensions in JavaScript. Looking at the replay API, we thought that there was a great opportunity here to try to tighten this feedback loop for our detection engineers. Right, we want to be able to get them this information as quickly as possible so they can develop new detectors and test them out and move on. So we have our metadata. We have the information for our analysts. We've got the response, the actual rules, but we put in a verifiers section in our rule template. So every one of our rules has to have these verifiers in order to make their way into production. And this is meant to be just like normal unit testing. So in any sort of detector, we have a generic false positive event, because anybody who's been doing detection engineering for long enough has probably written a rule that fires on every new process event, right? So, and then that makes everyone sad when it goes into production and blows up your sim or whatever it may be. So this we have this default one that just runs it's a simulation of a command line that just says Soteria test. And we want to make sure that this should never fire in any of our events. So this is kind of table stakes, right? If we write a new detector and it fires on this, then something's broken and we need to fix it. And there's similar one for network-based detectors and those types of things too. But we want to make sure that we're testing based on the event that we have. So we can go and create another one here. Say name red server executing out of app data temp. Something descriptive, and then in the events, what the Lima Charlie API in this case takes is a list, a JSON list of individual events, right? So if you write a detector that's for multiple events or a series of events happening, parent-child relationship, it can handle that, or it can just be one event. So in this case, we'll go back to our event. Lima Charlie has this handy dandy copy event button right here. Pop back over into VS Code, and we can paste that in here. It's not great because it pretty prints everything. So in our VS Code extension, we just had a paste flat piece that we did in there. That way we don't have to go and hit delete, enter, inline, whatever, 1,000 times. And then we want to tell it whether or not this should fire. So should fire. In this case, we do want this rule to fire when this type of event happens. So we'll run this and we'll run our plugin, and this will run through and then say, hey, we're running this verifier against the generic false positive event, and it worked. And for some reason, now it's not checking up on that last one. Maybe I didn't save it. Oh, I bet it doesn't like that slash.
Yeah, I was just gonna say, I bet it's the backslash unescaped.
right. Well, that's the live demo gods. We'll get you
And
out.
you
Get
you have events for one of them and event for the other
Oh,
one. See it?
there
uh,
it is. It's always some mundane detail.
so yeah, I appreciate this is nice having when you're doing this at like a conference or something. You're just sitting up on the stage by yourself. But I appreciate the assist here. Let's give that one a shot. There we go. So now we have our verifier pass there, and it does work. So uh,
Epic. So Paul, so you could daisy chain 50 false positives there and 50 true hits there, and it's just gonna rattle through every one of them.
yep, and so that's where it becomes important, right? So as we deploy this rule, inevitably, at some scale, you're going to have some false positive conditions to say like, okay, this one app is always going to be doing this, so let's like exclude, let's write an exclusion condition for this one parent process for this, right? So if I don't know, acme.exe is the parent process with these parameters that are very specific that protect yourselves, then we would go in, we would write something like not, true. Uh, then we can just copy these things here and say, let's see, event parent command line contains, Acme, right? So now we've added this, and then we would want to go back and test it, right? And this one, oh yeah, you got to give it an op. So this is another thing that's nice, right? It tells us,
Oh.
hey, your rule fails now. It's missing an op in this thing, so we can go back in. You say op is,
And
test it.
Javier, I'm seeing your question there in chat. So the verifiers do two things. Yes, one of them is what you just said. It can run against a normal event to make sure the rule doesn't fire on a false positive, but he can also add what you would consider to be bad events to make sure that it does fire on the bad events. So it handles both situations.
Yep, that's right. So in this one, I just went and manually added the value acme into the parent command line just for the sake of testing here. And so we can go and run this again, and it's gonna fail, right? So let's see what the issue here is. Um, well, that's interesting.
Yeah, I'm looking for the same thing you are.
Yeah.
Uh,
Oh, I might have. I wonder if they can not be named the same thing. Oh, this has got to be contains. So we're saying if it contains the word Acme. So there we go. Right. So now we can go and add in these new false positive scenarios and say, okay, we don't want it to test it, and we leave all these in, right? So anytime we commit this up, it stays in here for the life of the rule that way. And most importantly, what you don't want to do is somebody to come in here and tune something that is going to break the intent of your rule. Or so if they go in here,
yes.
somebody tries to commit this and they edit the name of the binary or something like that accidentally, then it's going to fail and it's not going to go on to production.
Paul, I just want to just take a minute to really reiterate the importance of what you just said because you say it so cool and casually, but folks, this is a big deal, right? So say you're a seasoned detection engineer and you've been crafting detection signatures for years and you've really got a knack for it, right? And here you are ingesting your threat intel, looking at these threat actor reports, and you're writing some bomb detections. You're just like, oh yeah, this is going to catch the thing every time, no matter what they try to do to throw us off, we're going to get it. Well, that all that tribal knowledge of how and why you wrote that rule, that's in your head. Once the rule is in production, right? Like nobody knows all the stuff you thought about, all the testing you did, and all the pitfalls that you encountered. And when you put that rule in prod, somebody comes along 3 months later and they're like, why did he do it like this? This doesn't make any sense. And then they go and they change it, and they go and they tweak it, and they go and they make different changes. Well, you can codify your intent, which exactly what Paul just said. You can codify what your intent was when you wrote that rule. I want to make sure it captures any variation of X, Y, Z, YZX, XYZ, and all the various different ways it could happen. And then you codify those in the verifiers. And now if some other analyst comes along and makes a change because they didn't understand your intent, and now it's failing the verifiers, well, this rule doesn't get neutered now. It doesn't get, messed up in a way that it's not going to work the way you intended it to, right? And I just think that that's brilliant. That's epic. It's a way of checking your own work and making sure that that work continues to get checked in the future for the lifespan of that rule. And I think it's brilliant, Paul. I don't know any other team, and I've worked with a lot of teams. I don't know any other team that's taken it to this level. And I think this is an outstanding example of how it should be done.
Yep. And Jeff, you're right that I did like intentionally misspell this just to show that things will break if we go do this. And yeah, that's right, Eric. And ideally, you'll have people that capture all this stuff in Jira, as I'm seeing in the chat, like having the GitHub issues or Jira issues that do this. But people don't always document those things very well. And realistically, are people going to go back and read that as thoroughly as they should? So it captures that intent, codifies it, as you said, and it prevents people from making those mistakes. So it just can't go into production if these don't pass. But the other thing that we saw, and I made this mistake here on the demo, right? And I do it all the time. You write a rule in a way that is just not right, but you miss a keyword here or there, and it just doesn't pass. And it's a frustrating thing for a detection engineer when you're writing rules and you put it through the deployment pipeline. And even if that takes 5 minutes to deploy out to all of your organization, it's pretty quick, but it's a long feedback loop, right? So the purpose of this is to tighten that feedback loop and like, let's get this testing done as quickly as possible. That way we can make sure that folks have the information they need to make sure they're doing it right the first time. So you don't have to redeploy 2 and 3 and 4 times.
One other huge benefit I see to this, Paul, is that, okay, so you just went through and basically emulated the threat so that you could get the telemetry, right? And that's awesome. And I think a lot of folks should be doing exactly that. But what I love about your approach here is that in theory, you could just simply fudge that event. You could take that like template there that you have for that event, and you can make it say whatever you want. You could type in any values, any parameters, but you could fudge those events to be whatever you want them to be so that you can test all the variations without having to emulate every last variation.
Yeah. Yeah. And that's absolutely, like, you have to sometimes, right? Like if you want to, like if we need to put together a quick rule to do something, sometimes you can't spin up the whole Exchange server infrastructure to test out this new detect. So you have to like understand what those parameters will look like. You can fudge it and you can go back and test it later to confirm your hypotheses. But if you don't have some piece of software that we know is being exploited out there in the wild, and we need to have a detection for it, we can go ahead and build that detection, synthetically create the the events of what that would look like, and then we can go back and verify that after some period of time.
Jeff's got a couple good questions. So he says, Paul, how do you ensure that all the rules in GitHub are also enabled inside LC? I can take a stab at that. Paul, you might have another. But one, Jeff, what you can do is, when you push the configs from GitHub into LC, it's an additive push. So it's not going to overwrite things. So there's a possibility that maybe the state of the rule in LC doesn't get overwritten. But I'd have to test and check to see that. But I'll tell you that the smarter way to kind of remove all doubt is, you don't have folks with the ability to go in and mess with rules inside the platform. You have that being the single source of truth being GitHub. So only GitHub's API key has the permissions to push and change and modify rules. No, you can maybe only view rules in the platform. You can't enable, disable, or modify the contents, because then you lose that parity.
Yeah, it's different for every platform, but you're spot on there, Eric. It's using API key flare with the service account that's pushing these rules through these GitHub actions. That way they're not visible and they're locked, and only that API key can modify that content and those types of things.
And then he's also asking where the verifiers are running. It's not on your host, since that's Mac OS, right? And Paul, if I'm correct, I think you're leveraging the LC API to run those verifiers.
That's right. So basically, we re-implemented this piece of functionality in JavaScript, because that's what VS Code requires. But you can do the same thing in Python. And this validate rule, this is the Lima Charlie Python API docs. So this function,
is it running it on a real endpoint? Is it like a test agent endpoint, or?
No, it's a replay API. So the replay API, what it does is we pass. Geez, I lost my my VS Code window here. But it passes the content of the rule, and it passes these events to an API on the Lima Charlie side. And then
so it's the event in isolation, not as if it triggered on a real box, but isn't on a real box. So you could copy a real event to make sure that is a true positive.
Yep, correct. And the replay API does support multiple events too, right? So you'll notice that if you can see it, it's a list, right? Currently, this list has one event in it, but you can do multiple events within one verifier. That way, if you want to have you know, if this happens within 2 or 3 times within a time period or whatever it may be, you can trigger those types of detection scenarios too.
Well, hey, folks, I know we are hot and heavy in some really exciting stuff. And Paul, I hope you'll drop some additional links and resources. I know Jeff asked the question. I know others might be thinking it. Is this VS Code extension ever likely to hit the open source webs?
Yeah, I am very interested, and we've talked about this. Would like for it to. It does, like, it's very tied in right now with a lot of our
Sure.
infrastructure. So trying to figure out a way that we can decouple it from what we're doing with a lot of our stuff. And you know, if anybody
Understood.
wants more information, it's I saw Whitney said it's secret. It's not really secret sauce. Like, I'd love to share it. It's just not something that we could do in a way that would be useful right now. But if anybody has questions, reach out, and happy to walk you through exactly how we did this or share some insights into it. So one day would love to open source it, but not right now.
I totally understand, man. Totally understand. Still think it's awesome. It's great inspiration. I hope everybody takes a little bit of a takeaway from that as to where you could aspire to get with your detection engineering processes. Thanks so much for joining us, Paul. Hey, folks, next week, same time, same place, we've got Olaf Hartong on. So super stoked about that. Hopefully, most of you know Olaf and the awesome contributions he's made to the space. Paul, so great to have you. Hope to have you again real soon. And folks, keep in mind, keep the conversation going in Slack. We've got a Defender Fridays channel right there in our public Slack. You can get there at slack.limacharlie.io. And happy to chat with you. Take care, everyone. We'll see you again next week. Have a great rest of your Friday.